Hello students. In this Learn by Doing activity, we're going to go through the process of factoring a few polynomials together. But instead of just watching me do the problems, there will be several places where I'll ask you what the next step is, and the video will pause to give you a chance to decide. This is a great way to see whether or not you know how to choose and apply the different factoring methods. Let's begin. Factor 3xy squared minus 12x. What's the very first thing we should try to do in this problem? We always want to start by factoring out a GCF if possible. In this case, there is a GCF that we can factor out. What is the GCF in this problem? In this case, the GCF is 3x, so we can factor out a 3x from both of the terms. When we do this, we're left with y squared minus 4 as the leftovers. Now that we've dealt with the GCF, we can continue to factor the rest of the polynomial. Which method should we use to factor y squared minus 4? We notice that this is a difference of squares. In fact, y squared minus 4 is a binomial, and the other choices were only applicable to trinomials or polynomials with 4 terms. So we're going to use the difference of 2 squares. When we use the difference of squares formula to factor y squared minus 4, what do we end up with? We know that y squared minus 4 can be factored into the sum y plus 2 times the difference y minus 2, and we have to remember the GCF out front. So we get 3x times y plus 2 times y minus 2. And since none of these factors can be broken down anymore, this is our final answer. Let's take a look at another problem. Factor 4y cubed plus 12y squared minus 40y. What should we do first here? Again, we always want to start by factoring out a GCF if possible. And in this case, there is a GCF we can factor out. What is the GCF here? In this case, the GCF is 4y. So when we factor this out, this gives us 4y times y squared plus 3y minus 10. Now that we've dealt with the GCF, we can continue to factor the rest of the polynomial. Which method should we use to factor the rest of the polynomial? When we look at the rest of the polynomial, we have a trinomial, and the leading coefficient is 1. That means that the easiest method is unfoiling. In this case, we need to find two numbers that have a product of -10 and a sum of +3. What are these numbers? The numbers we're looking for are +5 and -2. Thus, we have y plus 5 times y minus 2, and our final factorization is 4y times y plus 5 times y minus 2, because none of these factors can be broken down any further. Let's do a couple more examples. Factor x cubed minus 3x squared minus 16x plus 48. Is there a GCF that we can factor out here? No, in this case, there's not a greatest common factor that we can pull out. x cubed and 48 don't have any common factors other than 1, and pulling out 1 doesn't help, so we move on to choose a factoring method. Which factoring method should we choose here? Because there are 4 terms, we should use factoring by grouping. So we'll look at the first 2 terms, x cubed minus 3x squared, as one group, and then the last 2 terms, negative 16x plus 48, as the other group. In the first group, x cubed minus 3x squared, the common factor is x squared, and when we pull that out, we're left with x minus 3. Let's look at the second group now. What should we factor out of the second group? Here we notice that both terms have 16 as a factor. However, we want to pull out negative 16 so that the leftovers are positive x and negative 3, and then we have the same thing in each set of parentheses. Since each group has a factor of x minus 3, we can pull that out as the GCF of the groups, and then the leftovers, x squared minus 16, go in parentheses. Now, are we finished, or is there something else we could do to break things down further? Because x squared minus 16 is a difference of squares, we can break that down further. We'll keep the x minus 3 out front, and x squared minus 16 becomes x plus 4 times x minus 4, and now nothing can be broken down any further, so this is our final answer. Let's do one more. Factor 4z squared plus 10z minus 6. First, we have to ask ourselves if there's a GCF that we can factor out here. Yes, we can factor out a 2 from the polynomial, which gives us 2 times 2z squared plus 5z minus 3. Next, we need to choose a factoring method. Which factoring method should we use to factor 2z squared plus 5z minus 3? Because this is a trinomial that has a leading coefficient other than 1, we can either use the AC method or trial and check. Let's go through the AC method. In this case, what is the product AC? Here, A is 2 and C is negative 3. So in this case, the product AC is equal to negative 6. Also, the sum B is equal to 5. So we want two numbers that have a product of negative 6 and a sum of 5. What are these numbers? The numbers we're looking for here are positive 6 and negative 1. Since we're using the AC method, we need to split the middle term using these numbers as coefficients. I'm going to keep the 2 on the outside, and I'm going to change the parentheses to brackets just to keep the 2 out of the way and keep everything organized well. So we keep the 2z squared there, but then that 5z becomes positive 6z minus 1z, and then we still have that minus 3 at the end. Now, what should we do next? Since we have 4 terms in the brackets, we will finish off by factoring by grouping. We'll keep the 2 on the outside, and then in the brackets, we will factor by grouping. The first group has a GCF of 2z. We pull that out, and we have leftovers z plus 3. In the second group, we can pull out a -1, which also leaves us with z plus 3. And so between the groups, our GCF is z plus 3. The leftovers are 2z minus 1. And of course, we can't forget that GCF of 2 that we had in the beginning. So we end up with 2 times z plus 3 times 2z minus 1. If we wanted to use trial and check instead of the AC method, we could have done that. We know that to get 2z squared, we would need 2z and z. And then because the product is negative, we end up having either a plus and a minus, or a minus and a plus. And because the constant term is -3, it's either going to be a 1 and a 3, or a 3 and a 1. And you can try a few different options, but in the end, 2z minus 1 and z plus 3 is the option that works, giving us the same final answer, 2 times 2z minus 1 times z plus 3.